Okay. Hello, everyone. My name is Sharaf, and I will be hosting the fourth session of this STEM Week presentation day. So now we'll start the presentations of our students like projects. So we'll start off with our first presenter, Sasha.
Can everyone see the screen?
Yes, we can.
Yes.
Dear friends and teachers, I am Sasha, and today I will be showing my project, which is a vacuum cleaner. So you might be wondering, what is a vacuum cleaner, or like, with what did I make it? So first of all, I will tell them what have I used to make a vacuum cleaner. So I have used negative wires, positive wires, a pipe, a bottle, a small fan, motor, battery, black scotch tape, hot glue gun, scissors, and a piece of knife. So how did I make a vacuum cleaner? So to make a vacuum cleaner, at first I cut the bottle in half, and then I placed the wires, motors, and the fan. I also cut some holes through the end of the bottle with an adult's help. Then I placed the net so it could collect up the dirt and secured it using a black scotch tape. And then at last I put the pipe in place for the dirt to come in, and now I will show you how it works. Clean up. So this is my vacuum cleaner model. And as you can see, for example, this is the dirt over here. So it can be either the dirt or dust or whatever the vacuum can pick up. So now I'm placing it right over here, like all together like this. Now over here, I will be turning on the switch of the vacuum cleaner. As you can see, like over here, you can see that it has collected up a little bit of dirt. As I've demonstrated it as like small paper pieces, so it is paper, so it will work with dirt. Just for the demonstration, I've showed it with paper. As you can see, the dirt or paper is right over there inside the vacuum cleaner, and it totally works. So, as you saw that the vacuum cleaner actually works, but how does it work or how does it function? So at first, the vacuum cleaner gets a lot of air pressure. The speed of air increases and the pressure decreases. Air will always flow from a high pressure area to a low pressure area to try to balance out the pressure. In general, a vacuum is created by starting with the atmospheric air pressure within a sort of chamber. Now, as the molecules are removed by the vacuum pump, the distance between the collisions becomes greater and greater. There are many different types of vacuum cleaners, but all of them work on the same principle of creating negative pressure using a fan, trapping the dirt and cleaning and releasing the exhaust air. This process is also used in industrial machines, as in factories, there are different machines. Some machines also work just like the process of the vacuum cleaner, in real life. So we use vacuum cleaner in different places. Uh, when we use, it can be used like this one, which I made, is portable and small. So it can be used to clean dirt over our house, and also it can keep the environment clean. Thank you. This was all my presentation. Good afternoon.
Wow, that was such an amazing presentation, Sasha. It's so amazing that how you just made a vacuum cleaner from a bottle you used at home. It was truly amazing. So now we'll now move on to the next presenter, who is Shushudo.
Hello parents, and welcome to my presentation on engineering. In this year, I have chosen engineering as my subject for STEM, and I have built a roller coaster. This is the picture of my project. The resources I needed for my project was empty tissue paper rolls. I have reused empty tissue paper rolls for my project, which was the main ingredient I needed. Except for that, I also used mortar, wires, and tape. So, how does my roller coaster work? How does it work? How does my roller coaster work? First, it goes up, using kinetic energy. The roller coaster first goes up using kinetic energy, and then it turns into potential energy. Kinetic energy is the energy of an object in motion, and potential energy is the energy stored in an object. So, when the roller coaster goes up, potential energy is produced. The maximum kinetic energy is produced when the roller coaster is at the bottom of the tracks. When the roller coaster goes up, the velocity increases because and the force of the gravity increases too. But when it goes down, the roller coaster goes faster because the gravity allows it to go down. By doing this project, I have learned more about kinetic and potential energy, and also I learned about how the force of gravity works. I have also learned how this theory can be used in daily life and how a roller coaster works. How can it be connected to real life? This theory can be used in real life in real roller coasters, elevators and lifts, or in other objects and areas. That was my presentation. Thank you for watching.
Wow, that was also such a great project. It showed how the different energies used in real life and how it works. That's really creative. And now let's move on to our next presenter, who is Tashin. Um,
Ashin is
I
absent
think
today.
Tashin is not here because of some technical problems and is disconnected. So we will move on to our next presenter, who is Zain Mahmood Khan.
Good morning, dear friends and teachers. Today, my topic is natural satellites. Natural satellites. Natural satellites are an object that orbits another object on a planetary scale. Regular satellites. To understand what's a regular satellite, you first have to understand what's the Roche radius. The Roche radius is something which surrounds everything in space. If a smaller object comes into the Roche radius of a larger object, the smaller object gravitational field disables. So regular satellites are created when rings expand beyond the Roche radius, so particles collide with each other and form regular satellites. Irregular satellites. You can consider something an irregular satellite when it's far enough from its host that its orientational plane its orbital plane and its orientation is controlled by the sun. To see if something is a irregular satellite or not, you first have to compare the semi-major axis with the Roche radius. If the apside is above 0.65 or the distance is above 0.65, then it's considered a irregular satellite. Trojan satellites. Every single object in space has certain points. If you if you count L3, L1, and L2 points, you make a line. If you count 60 degrees from that line, you will get L4 and L5 points. So Trojan satellites are sub-satellites which orbit from those points. Sub-satellites. Sub-satellites are, as the name suggests, satellites of satellites. There are no currently known sub-satellites which are not Trojan satellites, but Saturn's moons Rhea and Leptus are thought to have sub-satellites. Temporary satellites. Temporary satellites are space debris which are caught by a planet's orbit. For example, 2020 CD3, 1991 VG, 2006 RH120. Asteroid satellites. Asteroid satellites are small rocks or particles which orbit a asteroid. A few examples will be 243 Ida's satellite Dactyl, 87 Sirius satellite Romulus and Remus, and more. Since I've explained the basics of all the types of satellites, let's see if you can point some of them out in this picture using annotation.
Okay, I think our friend Zain wants you to participate through annotation.
Okay, you can annotate by pressing on the view options and pressing annotate. Okay. This is an sub-satellite because it is like moving away or temporary. And this is a planet.
Yes.
Yeah, I think. Yeah, this is the main planet, but that one is actually a
Temporary. Sorry.
yeah, that's a irregular or temporary. You can also consider it a temporary.
Okay. Zain, are those all the satellites?
No, technically everything that surrounds this one rock in the middle is considered a satellite. Most of the things here
Okay.
are
Okay, so those debris are satellites too. Okay,
yeah. Okay,
very informative.
Yes.
that's all. Thank you for listening to my presentation.
Okay, thank you, Zain. That was very informative about the different satellites in our solar systems. It was very informative and also creative project. And now we'll move on to our next presenter, who is Zain Salangazi.
Miss, can you see?
Yes, we can see.
Okay.
I think you need to give the sound.
We can't hear it, Zain.
Try to screen share again,
Oh,
enabling the sound.
Yeah, with the sound.
like at the bottom, you'll see share with sound.
Hello parents, today I'll be showing my science experiment called the air pressure. So what is air pressure? Air pressure is the pressure within the atmosphere of the earth. The standard atmosphere is a unit of pressure defined as 101,325 pascal, which is equivalent to 760 mmHg. I want to show with a simple experiment that it exists. So basically what I'm guessing will happen right now, if I open the cap, the water will pour out, but as it's closed, there are 3 holes in it, it's not pouring out. So let's test it if it works. And as you can see, the water is pouring out. So now, why is it pouring out? It is mostly because the atmospheric air entered inside the bottle, which gives pressure water and the water pours out. But as it's closed, the atmospheric air cannot enter the bottle. So it can't give the pressure and it's not pouring out. As you can see, it's not pouring out. So what I have learned is this, that atmospheric uh, air gets in the bottle and gives pressure, but if it's not inside, it cannot give pressure to the liquid and it will not pour out. Thank you.
Done.
Okay. That was really also very creative and like awesome project. How you showed air pressure in like and then bottle using a colored like water. That was very amazing and thoughtful. So now, parents, like, do you have any comments or questions about any like anyone's project?
Sarah,
Zunaira is left, Sharaf.
Oh, sorry. Okay, next is Zinaira's presentation.
so good afternoon, dear parents, friends, and teachers. I'm Zanara, and welcome to my science project of this STEM fair. Greetings to all of the parents, teachers, and friends. I'm Zanara Nawaz, and welcome to my science project of this STEM week. So, after seeing this project, I hope you can recognize what it is. So, it is a hydraulic rig. So, let me tell you what are the equipments you need for making this project. The first thing you need is wood. Then you need syringes, cardboard, a long tube to connect them, and also you need super glue and glue. So now I'll show you how it works. So now I'll be talking about this project. So what is a hydraulic crane? A hydraulic crane is a type of heavy-duty equipment which is used for lifting heavy objects. Hydraulic cranes have their own internal hydraulic system which allows them to lift things. Same way, I have used steering gear to replace the hydraulic system. So,
Um, I think Zinaira, you're having some internet problems. It's not loading. So
Okay,
Sunaira, the video is published in YouTube.
I'm going to share it from the classroom, Zunaira. You can stop screen share.
um,
Okay, I think she's having internet issues.
okay, then
She
Miss,
got
do you
disconnected.
have the video of Zinaira?
Yes, I will try to look for it. In the meantime, you can interact with your other participants if they have any review or remarks to share.
Okay. So So now I'll ask the presenters and the students now. So the ones who presented, like what challenges did you face during this project and what like profiles you think you developed during this project? Um, okay. Zain Muhammad Khan. Okay, you can
Yeah,
tell your challenges.
the challenges. Yeah, the challenges were extreme. Like first, when I made my model, it first looked disgusting. Like it didn't even look like a model. When I told Miss, then Miss said to find a second option. So I thought of improving it. I improved it a little bit, but when I went to present it, it didn't work because I had to twist it around. So I made a slide, went around my challenges, and then thought of like a game where the parents can participate and annotate. That was
Okay.
my first.
So that's such a creative idea how you like overcame your challenge. That's so amazing thing. Okay.
Okay,
And
Zonara is
now
back.
what
I think,
profiles do you think you developed?
Sharaf, would you like to ask Zonara if she's ready?
Um
Zonara is here.
okay.
Zonara, would you like to start?
Yeah, okay.
Unfortunately, the video is not coming, so I guess I won't be able to show it.
Okay, do you want me to screen
Okay.
share from the classroom?
Yes, miss.
Okay.
If the video is downloaded, then it won't need any internet, so she could play it from there if she wants.
Greetings to all of the parents, teachers, and friends. I'm Zinara Nawaz and welcome to the science project of this STEM week. So, after seeing this project, I hope you can recognize what it is. So, it is a hydraulic crane. So, let me tell you what are the equipments you need for making this project. The first thing you need is wood. Then you need syringes, cardboard, a long tube to connect them, and also you need super glue and glue. So now I'll show you how it works. So now I'll be talking about this project. So what is a hydraulic crane? A hydraulic crane is a type of heavy-duty equipment which is used for lifting heavy objects. Hydraulic cranes have their own internal hydraulic system which allows them to lift things. Same way, I have used syringes to represent the hydraulic system. So, here due to the air pressure from the two syringes, the crane is able to lift the objects. You can see if I pull the syringe, the air pressure is released, for which the crane does not get the energy to lift the thing. But when I push it, the crane is boosted up to uplift the heavy objects. In real life, these hydraulic cranes are easy to handle and can lift heavier objects. They are used in construction areas. So, who invented this? Hydraulic cranes and other hydraulic machineries were firstly invented by Sir William Armstrong. The real-life application of hydraulic cranes are that they are very easy to use. So, it is used in various construction areas as they need to lift many heavier objects from here to there frequently. So that's all about this project. Hope you like it. Thank you for joining me.
Wow, that was very unique of an idea of using wind pressure to move mechanisms. That was truly amazing. And that includes all of the presentation for this session. So now, as we were talking about before, about the challenges and the profiles, like the presenters face, like the students face. Okay, so does anyone want to share what challenges and profiles developed? Okay, anyone?
I think our meeting is going to end in less than 1 minute. We can join back and have further discussion.
Optimus. So after joining back, we'll continue our discussion.